How's it going, everyone? Welcome. Eulero Gonzalez here. And today let's going to continue to look at this particular exercise from the chapter 4 or chapter 3 in this Getting Started series of You Don't Know GS Yet, written by Kyle Simpson, a software engineering with over several years of experience, more than 20 years of experience. He made this book not for beginners, which is I do find that is quite interesting, but those for actually professionals that are in the fields that they want to truly understand how the things work and be competent on that. So, in other words, this series of videos that I'm recording here is just to explore that. And as I did this, it turns out that, well, in the chapter 1, 2, and 3, which is what I'm currently at, okay, we explore is all of these particularly topics, all right? I don't know why. That's interesting. That's very interesting. It's like you're not loading the current screen or the proper screen. What about now? There you got it. All right. So in the chapter 1, I'm gonna make a quick recap here, very quickly, right? So in chapter 1, which is what is JavaScript, we went through understanding what is the name, who makes that, who now owns the legal trademark, and also who oversees the language in itself from a technical perspective, known as the TC39. What this group is, who made this, what is the role on the entire, or how this commit fits into this entire thing as part of the guarantee that the web won't break, which is part of their motto. And because of this, they follow is a particular process, which is when a proposal or a champion go through stage 0 to stage 4, right? And because they now they don't know the reality, not because their lack of competence, is because it's massive, and JavaScript implementations actually now are exposed to the reality. Sometimes they have to go back to the drawing table and then redefine the proposals. There was a particular event happened circa 2010s, known as the Smushgate, which shows that that what I mentioned. But most of the times, those JavaScript implementation must stick to the law, and because these JavaScript implementations can be run on different environments, whether it's a client, server, light bulbs, robots, the only reality that matters is the web. And because the web provide now developer tools, convenient developer tools like console, to check if this a valid JavaScript or a small snippet of code, this environment is not true JavaScript spec compliant. This is a friendly JavaScript, and I can make a case for that. I can show you why is that. For example, anytime that you want to create now you define a function with the use strict, how the use strict is applied by system, not as the way how JavaScript works, which is per file or per function, and among other features, right? And in order to guarantee this backward compatibility, unlike the HTML and CSS, which is forward compatibility, well, we have things like polyfills and shim, which says, hey, this is now the community logic to provide now feature for older browsers, right? So we can remain now on the edge In other words, still using is the latest features of the JavaScript, but those browsers that doesn't support, hey, this is the logic here, this is the behavior here, right? And also, how can we now use JavaScript for different problems that we have, such as the functional programming or the object programming, procedurals, and another thing is that the JavaScript in itself is not an interpreted language. Is in essence, if not in practice, a compiled language. And it all boils down is that how JavaScript process errors, the error facings, which is now is what compilers actually do behind the scenes, right? When they have this particular phase, the parsing phase to detect early errors, this is what now the line between an interpreter and a compiled language, at least in JavaScript, that line um, is erased, is blurry, all right. So because of that, we also look at how now JavaScript process your file, okay. And because of this, there's a concern about the speed of the language when it comes to parse and execute the code. So Wasp emerged now as a spiritual successor, something called ASM, which was a bunch of engineers at Mozilla that now make a great precedent to pour this Unreal Engine into the web that run at full 60 FPS. So the thing here is bypassing directive and telling the JavaScript engines so by passing certain hints of the JavaScript engines that we can, as developers, JavaScript developers, perform some optimizations to the JavaScript engine. This was not meant to be authored by JavaScript developers, but it turns out that it set now this precedence that this is capable, that the language is fast enough to do that. And because years by and Wasp now came here and say, hey, it's gonna push things forward by skipping the parsing phase, and then anytime that you have a particular code in any different environment or language, right? Whether it's Java, C Sharp, you want to pour that using this, or you want to compile that using this WebAssembly, that is going to output code that it can be run in any of this Wasp environment or Wasp runtime. So now Wasp become this universal compiler targets, which it looks like as like an assembly, all right, that has these intermediate representations of your code. So again, this is not meant to replace now JavaScript. It was to now understand that how the language can be actually used in order to run other codes from other environments, from other languages. So when it comes to also understand this particular feature of JavaScript, which is a strict mode, is to say, hey, this is just a guidelines that developers follow to do the right things that provide a good chance for the JavaScript engines to do optimizations and I'm sorry. So the strict mode, exactly. So the strict mode is now this rules that developers follow in order to now provide some hints so that the Java is not provide hints, because it's this set of rules that developers follows to do the thing the right way. So now the JavaScript engine has a good chance of optimizing and executing your code. So this strict mode now enforce certain things to do in order to let the JavaScript engine to now optimizing and running our code. So this is just the section 1. And then the section 2 we describe is, well, serving JavaScript. So as you can know at least a high overview, all right? So first thing first, we look at how now the JavaScript engine actually see a particular file. Each one of those are standalone files. So each file is a program, and the only way that they can act as a single one is if they share the state, whether it's globally or if they share now that state or they expose that state. So other standalone files, programs can interact with. In the EX6, because now we have this loading mechanism, this is another way of how different files can cooperate at runtime and having this interoperability amounts in. So the point is that no matter how code organization you use or loading mechanism, it is still great to think that JavaScript in itself, JavaScript engines see each one of those files as a single program. So this program that is made of values and values is something that we used to represent and manage the inner state of a program. There are several of them. We have now primitive, string, and boolean, that each one of them follows specifications. So string, the Unicode, number, the IEEE 7054, that describe is how it's going to be represented in the computer along some other behavior that it has. We also have the boolean, the begin, the symbols to actually obfuscate data that is not even accessed by the developers. And this is useful for low-level libraries or frameworks, and the kind of emptiness, undefined and null, and the subtle nuance with null. So last but not least, the other type of value is objects. And in object, you have different labels here. So you have now an array, which is an exotic object, okay? It's just a fancy term that they use, but this is an array, a numerically indexed sequence of values, that inside of that you can have also is all of these values that I mentioned, as well as an array and objects and functions, okay? So object is a schema value, and also we have now functions, and functions are values at the end of the day. So if you're new to this, it might be quite counterintuitive to understand that functions can be valid, but yet this is quite powerful, because now you can hold inside of a variable, which is like containers as values. You can hold now is a set of instructions in these containers, in these variables. And the way how can we define variables is has different syntax form, whether it's var, let, and const, which act as a scope, and again it has inherent behaviors. And also you can define variables via the functions declaration, all right, where they're binding, where the binding between the name and the value happens at parse time. And also you can define variables inside of the function as parameter, right? And you also have now in the try catch is this variable defined as error. But this is the different place where you can define these variables. right? And because functions are something that you can now put inside of these values, or inside of this variable, inside of these containers. Now, variable functioning in itself is something interesting or the way how behave or the roles in JavaScript is quite interesting because you have now procedures or mathematically function, which is a strict set of rules that all functions must abide, or you have this procedure, which is a set of statements that you may pass one or several inputs and it might return one or several outputs, and you might call this procedure once, for example, a configuration, or several times, right? So, but the thing here is that this role of functions is something important as we explore that in the next chapter, the chapter 3, because now functions have these roles, all right, and because we can now assign as functions as values in other objects. So for example, in objects and in arrays, it allows us to understand that we can now carry over is this set of instructions. In other words, it unlocks a new way of thinking that we can now help. You can think of this like you can carry now a set of instruction in your pockets. So for example, your cell phone is indeed like a function that you held inside of your pocket, like a function that you held in the variables. And that's quite interesting because, again, it unlocks this particular mindset and also functional patterns. Functional patterns that we're going to see that later. So, for example, high order functions, how you can now dynamically is as how you can dynamically load functions in objects, all right, as a way to now load some specific configurations. Hey, I do find this, so let me now load this configuration as it is. Also allows composing or composition of all of these functions or piping, as well as allowing to describe is function purity, which is, hey, when you define these functions and anytime that you call these functions, it won't affect the in an unexpected way the rest of the program. All right, it will give you now an output, the same single output, which is now deterministic, and therefore, well, you can have now this guarantee that it will make your applications easy to debug and to understand, but especially easy to maintain, because now that particular section of your code that follow those principles, particularly the functional programming, you can now rest assured that it will behave as it is. So then we also look at the other features in JavaScript, which is the comparison and the equality. So how now in the comparison we have now a particularly operation, abstract operations, and it called abstract because it happens without your consent. It happened without even you, without even your consent. All right. It is part of the language. So, for example, the double equal, triple equal, how that behave, what is doing behind the scenes, and how important it is for us to understand that what referential identity means, which is the way of how now these are comparing in each other's. And anytime that you now assign or pass a value, whether it's a primitive or an object, a primitive, unlike any other language, you can specify how you're going to assign or pass. But here, it's based on the type of values. So if this is a primitive, the value is copy. If this is an object, it pass now as a reference. And also is when you want to convert is the type of these values from one place to another, or from primitive to another primitive, or from primitive to an object. It also follows is an abstract operation that has a well-defined rules in the spec that say, hey, this is how we're going to do this kind of stuff. So not only that you can be explicit about, there are certain places which is I and also fell sure that this coercion happens. So for example, if statement or while statement, right? It's going to coerce that into a boolean, all right? So the logic that you define there is important, that is evaluating as a boolean value, because that value will be coerced into a boolean. And we also look at what is the possible false C values and true T value, all right? And that is all about is the comparison in equalities and coercion, right? Also, we look at how can we now organize our code, or how our programmer has organized the code here, okay? Whether it's by using the new syntax, which is the class, which is the way of how you can define is a custom type value that has its own data and its methods that you can operate on that data. So I really love to think about these classes as a value that you can define, a value that you can use, right? And remember, the value is the most important unit of information that allows us to maintain is the state of our program. Hey, this is the current state of a program. So now class allow us to do that, right? We also see how can we work with that, and this is part of the co-organizations, and also is how can we now is look at the other way of organizing our code, which is as a function, which you're going to return as the API, or now is the EX6, which is not that old, is actually the standard here, where each file is now a model, right? Using the import and export to actually is make all of these files act like a single one at runtime, do this interoperability that happen. In other words, anytime that you import another variable from another files, or if you import in several files from another files, so what happened is that, well, this particular file that is making all of this call to import certain variables, containers of values, now this file is acting now as a so this file, when it linking to all of this, or when it now importing all of these variables, all of those variables as well from other models are now act like a single program. But it turns out that this file that you are executing is the main program, sort of speaking. But I do find that this is quite interesting because you're going to see that a lot in your programs, in your, whether it's building a web app, or if you are not on the server. So each one of those files act as a single program. So this all end the discussion about the nature of or the serving of JavaScript, all right? Which I can summarize this in that each program is a file, values in our programs, the primitive and the objects, and the subtle nuance of that. Function is another value, and how can we now using and declare those variables instead of using and declare those values instead of values, using and declaring variables instead of those variables. Okay, what are the syntax forms, and where are the places we can define variables? How can we define those variables? And then what happens when we assign a value and when we pass that? And also, because now functions is another type of values, what is the role of functions in JavaScript? All right, where there's a procedure and a function, and how this behaves behind the scenes. So the other is a comparison, how the comparison happens in the language, and how the conversion of one type to another happens as well. And last but not least is, well, the co-organization, whether it's by class or functions or a model. And in the chapter 3, okay, we're now digging into the root of JavaScript by looking is at this low-level feature that happens in the language in virtually every line of code that we write, so we can understand now the ebbs and flows of JavaScript, the feel of JavaScript. So first is the iteration, at least right now in 2025, right? So we have now the iterations, which is conventions of how now we can consume data, because most of the time in our programs, well, we want is to describe is that a program process data, and then we can act, we can take decisions, we can make decisions on that data. Sorry. Let me actually oops, this is not. All right. Good. So this is the iteration. So because most of the program actually now are built essentially to process data and make decisions on that data. So this is why we have this convention, okay, that the algorithms that we want to set here to consume those data must be a standard way to do that. You can build your own, but that is make it your program hard to reason and to maintain. So this iterative protocol, which is described now, is a contract that it has a reference to the underlying data source, and then expose this contract as a function called next, that when we call that, we get the value, all right? And as well, the Boolean value, which say, hey, this is to indicate that are we done, all right? Iterating through that collection of data. If it is, good. If it's not, well, we can continue to call next until that it is done. And even though that is done, we can continue that, and that iterator we continue to give it that last value, unless we create now another instance that holds a reference, and we can now call the next functions and go over again. And when we create now this new instance, it's like starting from the beginning. Okay. So the way how this works in the XS, so the way how we can consume this is iterator, is whether it's a for of syntax or whether it's a spread operator that is behind the scenes. It's a hey, if this expression that we're going to evaluate, so for example, is in this case, if this expression or even this spread operator, if this expression that it can be is a conditional, this condition can be short-circuiting, whether it's and or nullish collisions, or even the ternary operator. It can be also is a arrow function. It can be an async arrow function. It can also be an assignment expression as well, which to me is quite weird. All right. But if that expression, and an expression is something that produces a value, if that expression, if that value that is produced by that expression is now a iterator, in other words, the way how it works is by this is, or this syntax is going to look at that particular value, and it's inside of that value that has this symbol, the iterator, which is a well-known symbol. And if you remember what symbol are, is this privately held value that in our case has a reference to this contract. So in other words, it say, hey, this object or this value now has internally a reference to the symbol iterator, which means that this value now it can be consumed. All right. So it describe is the contract that we can in. So this is something that, as we now describe here, and what are the values that we can iterate over, okay, which is part of the iterables, is, well, the protocol automatically create an iterator instance from an iterable, okay, exactly. But this is part of this protocol, this consuming protocols. It automatically creates now an iterator, this contracts that we can consume based on an iterable, based on a value that we can iterate over, and consume just that iterator instance to its completion. So this means that exactly, and it's going to consume that iterable, or it's going to consume that iterator instance to its completion. So this means that a single iterable could be consumed more than once. Exactly. So each time a new iterator instance will be created and used. So where do you find this iterable? Basically, we have now, for example, string, maps, sets, or any other iterable that has implemented that symbol.iterator, as I mentioned, right? That it say, hey, this is a value that we can iterate over. And this is just to describe that. And how can we use those iterables to consume them via the iterator protocol. And now all of this jargon becomes much more clear. So when it comes to look at another features of the language, which is closure, which is when you define a function, and so is when a functions have access, when a functions when a function's access or when a function's remember, okay? So when a function's remember and continues to access to variables from the outer scope, from outside, exactly, from the outer scope, even if the function, I'm gonna use my own words here. So a closure is when a function remembers the variables and continue to access from the outer scope, even if this function is executing in a different scope. In other words, is when you define now a function, usually, which is used as a function, and if that function has a reference to other variables, it's gonna remember them as it's gonna remember is it is reference, right? So because this is not the value that is remembered, it is the reference that is remembered. So we have now confusions, for example, in the for loops, right? When you use now a for loops with var, and then it's going to pass now is a set timeout. The thing here, and describe as a function here, the thing here is that, so this is part of the example here. By de facto, you say for, please create this. But if you do this, right, and bound this to say, hey, 7, I want to iterate through 0 until 6, okay? I want to include now 7, so it means that it will be 8, okay? And then I say set timeout, right? And then I'm gonna pass now a function here that this function will say, hey, I want to console.log is the index, right? So you effectively here are creating now a function. Creating is a closure. So you are closing over, say 1000, there you go. So what happened here is that this index value is passing as a reference, not as a value. And because for loop is now evaluating synchronously, and vars are not block scope, but functions or global scope, so by the time that this iterations is done, all right, and on each one of those iterations you are scheduling is this, you are scheduling this function here, and it is reference, right? So you are now scheduling is this, in our case 8 times, okay? And by the time that that is done, the reference here that now of a var is now 7, all right? And this is the value that is, this function is remembers. Remember is the reference, not the value, right? So by the time that this code is evaluated by the call stack, and now this index reached to 7, so a good example of describing is, so by the time that this for loops now is go through 0, and now schedule these functions, which now these functions close over the index, which is remember but the reference, not the value. And it's gonna do the same now for index 1 and 2 and 3 and 4 until it reaches to 7. So then once that is done, the value of the index, because it is a scope globally over function, now it is 7. This is the reference that is going to keep of all of this function that has been scheduled. Now this code is removed from the call stack, okay? And because this set timeout, now all of this has been scheduled is on a particular queue called the callback queue, okay? So when this code is done, the event loop is going to call is whatever is on the micro test, which is used for promise, until we call all of that, and we're gonna put all of this into the call stack until exhaustion. Okay, and the other is the if there is that is empty, it's going to look now at the callback queue, and then now evaluate that function. So when that function is done, so when a 1 second has been done, right? Now the function gets triggered by the event loop, all right? And then it's now put that function on top of that to be evaluated, and it put all of this sequence, all of these 8 functions on the call stack, and then it's going to evaluate that function, which is going to call all of those functions, which is going to print that out is 7 8 times. Interesting. 8. Why 8? Is index is less or equal than why 8? Oh, okay, of course it's 8. Because now it's including is 7, aka it's going to move to the another one. Okay, it's 8 times exactly. So you go from 0 to 8 to 7. That's quite interesting. That's quite interesting. So here what you're doing is, hey, this is the index 0, okay, initially, and then on the initial it will be now 0, okay, and then the index plus plus, okay, the index plus plus is that. So if I say this, seven, 6, 5, 4, 3, 2, 1, 0, and it's including is and it is including that. And it is including that. Exactly, and then now it is exactly. It's because it's incrementing that. Mm-hmm. Operator. Postfix increment, exactly. So what is doing this? Prefix increment operator. And it say, hey, if this is exactly prefix, you say let the expression be the unity. If the assignment target type is unity expression, is web compact, throw a reference error. Let the old value be the, let me coerce that old value. Okay, let me coerce that numeric to a numeric value. If this is a number, then let the new value be the number dot add plus 1. If not, let the old be is a big int and add this big int and perform put value, expression in the new value, and return the new value. This is if you put now like this. Okay, this will give you now is the new value. This will give you now is the new value here. Of unity expression. And this unity expression can be is the lead void type or this or update expression. Come on. Or update expression. Chill. Jesus. Okay, you're about to crash. Or update the expression. Can you static semantic early errors, delete. Is this one perform? Please be my guest. Assert assignment target type of unity expression. And then you say the update expression. Update expression can be left hand side expression, but it cannot be a literal. That's what happened. It cannot be a literal. Invalid left hand expression. Exactly. It cannot be a literal. This must produce is a value here. New expression, call expression, and option. So in other words, this must be something like this. It cannot be a literal. That's what happened. And what it's doing is this. Okay. So what you're doing here is, hey, this, I want you to return the, so I want you to get that value, add it, and returning immediately. Whereas the val here, you say, hey, I want you to increment that, all right? but don't return the new value. Okay, don't return the new value. The explanation is up to you, right? But this is going to return is the new value, which is 4, and so on and so forth. Again, it is very, very logical in how the things work. But my finding here is this. So if I say I'm going to index, and then I say from 0 to 7, okay? So here I'm going to go to 0, right? 1, 0, 1, 2, 3, 4, 5, 6, okay? And it's going to bring a 7, right? And it's going to, interesting. If I go through, so you're going to 0, because I'm not counting from 1. I'm not counting from 1, because if you're starting to count from 1, it's gonna give you now 7. If the index is less than 7, all right, because on each iteration what it's doing is that you say I'm gonna go from 0, I'm gonna go from 0 but because it's okay, it's because it's going to pass is now a reference to this. So this index is going to reach until 7. And it's because it's going to return is a new value here. That's interesting. You say, hey, -1 to 7, how many times it will call? -1, 0, 1, 2, 3, 4, 5, 6, 7. And if it's 7, it say no until here. So you're gonna call 8 times. And if the value is 7 is less than 7, all right. But if the value is less or equal than 7, okay. So my problem here is okay. and I'm having this issue here is because I do not understand how the for loop actually works. And there's nothing wrong with that. Let's get into this. On the iteration. Not this. The simple for, the simple fors, or the iterations. The semantics here. Do while for, like this, exactly. So it say this, look ahead, whether it is this or a lexical declaration, okay? Static semantic early errors, that's interesting. It actually evaluated that. If syntax error is labeled a function statement, is true. It is only necessary to apply this rule if the extension specifies this. It is syntax errors if any elements of the bound name or lexical declaration also occurs in the var declared name or statement. So if you say something like this, so runtime semantic for of loops. Here we are. Okay. For example, for var, perform the evaluation of a variable declaration list. If the first expression is present, let test be the first expression, which is this. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. And return for body evaluation, the test, increment, the statement, and the label set. And this is now lexical declaration of this. And creates now an immutable binding. Creating mutable binding. Let the all env be running execution context. So here it's creating now an execution context. Let the all env be the running execution context in the lexical environment. Let loop env be the new declarative environment of the old environment. Is content declaration of lexical declaration, and be bound names be the bound names of lexical declaration. For each element, the end of bound names do. If the con is true, then you're going to create now an immutable binding here inside of the loop environment, which is the new declarative environment. Let be the new declarative environment record containing no bindings. Declarative environment, declarative environment record is associated with the Javascript program scope containing variable, constant, let, class, model, import, and functions declaration. A declarative environment record binds the set of identifiers defined by the declaration contained within the scope. But it has that. It binds a set of identifiers defined by the declaration contains within the scope. Declarative environment record. Makes sense. Declarative environment record. It performs the following step when called. Let env be the new declarative environment record containing no bindings, and set the env and outer env to the end. It's okay. It's like having a reference to the old environment here. Interesting. So you are creating now this declarative environment record, what it's going to contain is all of this scope, and inside of this scope, all of this bindings, containing no bindings here. So you're creating is a record with no bindings, but now you're going to point the outer env to this all environment, aka to the running execution environment. So it's count declaration of lexical declaration. Let bound names be bound names, okay, of lexical declaration, and for each element the end of bound names, do for bound names be the lexical declaration of bound names. If count is true, then now inside of the loop environment create now an immutable binding here. Otherwise, create now a mutable binding here. So in other words, it's like you're saying is, hey, if you do this with let index, and then you say index plus plus, right? And you want to console log that, it will break that. Yeah. Can you please stop it? No, you won't stop it. Okay. Yeah. That's right. Good. From 0 to 10, right? Okay. Is the index of force you never execute this? Please be my guest. And it's gonna do that in a step of 2, right? Right. So yeah. So it creates now this execution environment, where is you have now let, you're gonna create now a mutable binding. If it's a cons, it is now an immutable binding. So for example, like this, and it say no, I cannot. Set the running execution context, the lexical environment to loop environment, and for declaration be complete evaluation lexical declaration, and in abrupt completion then do this. If counts is false, let per iteration let be bounds, otherwise per iteration let be the new empty list. If the first expression is present, let the test be the first expression, otherwise let the test be empty. Exactly, if you only have one expression. If the second expression is present, let increment be second expression, otherwise let increment be empty. It's a second expression. And body for body evaluation, which is what happened inside of the body. Okay, this is what happened inside of the body. The abstract operation for body evaluation takes argument, test, and expression parse, and increment, and per iteration binding and label set. Let V be undefined and perform the create per iteration environments, per iteration bindings. Repeat, if test is not empty, then create now a reference to that, get the value, transform that into a boolean, and if it's false, returns that. Result be completion evaluation of statement. If loop continue, result label cell is this. is not empty, perform create per iteration. If increment is not empty, is that. But I do not get it is, for example, is the for MDM loop. Okay, the initialization, the condition, and the after through. So what you want to do, okay, what you want to do after through you evaluating this code. Hey, I want to increment this. Okay, because if you don't pass anything here, this shit will gonna do that forever. You know what I mean? This shit is gonna do that forever. And say, no, I need the other one. So an expression to be evaluated before each loop. If this expression evaluates to the true, statement is executed. If the expression evaluates to false, execute exit. Execution exit. The loop and goes to the first statement after the for. And goes to the first statement after the for construct. This conditional test is optional. If omitted, the condition always evaluates to true. And the other is the after through. An expression to be evaluated at the end of each loop. This occurs before the next evaluation of the condition. Generally used to update or increment the counter variable. But in my case, my lack of understanding is this. If you say, if I want to increment that from 0, which is the initialization, and the condition is say, hey, index is greater, if the index is less than 7, I want to evaluate this expression, and afterthought, I want to increment that counter here, which is assignment here. Which is an assignment here. I do think that this might be valid. Because you're going to evaluate now an expression. Exactly. I do think this is valid because you're going to evaluate into an expression here. So you can actually indeed pass now arrow functions, so on and so forth. You can do some wild computations and then now return something here. So because of it, what it's saying is, hey, it's going to evaluate that exactly, but it's going to evaluate until 6. All right, and the question here is that when I do this with the set interval, okay, with the set interval here, You see? Because what you're doing here is say, hey, let me, but this is this one. Mm-hmm. Okay, close it. If the index is 0 and index is less than 7, hmm, that's to me is quite interesting with var. When you're doing this, it is exactly. It is true. It is true because it's less than, right? But is the index? If index is greater than 7, it's saying no. I'm gonna continue to that. But in my case, it's that hey, the first evaluation is 0. Then after through is going to say, I'm going to evaluate this, which is now incremented, which now is plus plus. And then, okay. So here is this. This is the initialization. It starts with 0, right? Start with 0. Yeah, but how is this things working, bro? Like other looping statement, you can use control flow statement inside of a statement. Yeah, but how the things is working? What do you want to know? What do you want to know about this? How this thing is actually being working? How the thing is actually being evaluated here? The scoping effect of initialization block can be understood as a declaration happened within the loop body, but just happen to accessible within the condition and after through part. More precisely, let declaration are special case by for loops. If initialization is a let declaration, then every time after the loop body is evaluated, the following happens. A new lexical scope is created with new declare variables. The bindings values from the last iteration are used to reinitialize the new variables, and the after through is evaluated in the new scope. So the after through is evaluated in the new scope. Using for without a body. Using for with two iterating variables. But my question is that what is doing, how is this being evaluated here? Do you know? How the things is evaluated? Time for clock for doing this. Where the following statement is declared in ECMAScript. So the condition is backward. Its index is greater than 7. Its index is less than 7. It's gonna do this. Okay, chill, chill, chill. Okay, Einstein. No, it is indeed. Because if your understanding of point me to the code. So is the for loop structure. The for loop initialization. The engine execute the index since index was already hosted. This just assigns the value 0. Condition check. And then it's gonna check the condition. The engine's evaluate is 0 less than 7. It's true and it enters in the loop body. Oh, it's going to evaluate until it's false. So it's going to evaluate this expression. It's going to evaluate all of these statements until this is false. Okay, and execute the loop body, and then update the expression, and then repeat the step 3 and 4. And that's what it's going to do. So it's going to, okay. So first is saying, hey, I want to know here. I want to know is. I'm going to define is this, right? Whether it's a count as a mutable binding or a mutable binding. But then is this. And is immediately check that condition. Let me see if this is true, my friend. It's okay. Okay, it seems that it immediately, exactly, completed. So your mental model is right. So it seems that it immediately evaluate that expression here. So it say, hey, let me the initializer, and then let me now immediately evaluate this expression, is this condition, all right? And if this condition is that, all right, makes sense, man, makes sense. So the value of this is that. So the value here is 0, right? So now, then, after you evaluate the block, the for loop block, then it's going to now run this, and in this case, update the index. So in this case, the index is now 1, and then it's going to check the conditions, and this is false. It's going to move to the next statement. So this makes a lot of sense of how this is evaluating here. Okay. So if I say for some reason is set timeout, and then I want to pass now is a function, because all of this was to create now a closure. Okay. All of this was just to create now a closure example. So what I'm doing here is to say, hey, I want you to now is go from 0 until okay. So the first time it's gonna say, hey, this is 0, the initializer. Gonna check the condition. If the condition is met, all right. If the condition is true, it's continue to do that until it is false. So by the time that it reached to 6, which is this is when it must stop. It say 6 is less than 7. Yes, it is. It's going to pass now. Yes, X is less than 7. Yes, it is. It makes a lot of sense that this is now 7, because what happened is that by the time that this index is makes a lot of sense. So it turns out that this is going to do this. It's going to go from 0 to 7, including the 0, 1, 2, 3, 4, 5, 6. All right. And because now it's going to call this 7 times, including that, which is 6. When you're going to pass that reference here, because by the time that now 6 is evaluated, okay, by the time now 6 is evaluated, 6 is less than 7, it's a yes. All right, go to the next one, and then now update that index to be now 7. So 7 is less than 7. No, but because it's holding a reference here, now the number 7 is going to pass that. So whatever value that you put here is going to be passed down there. So after 1 second, because we are incrementing that, that's right. But after, it's gonna print that 7, and it is because the way how this actually is working. So you gotta be very careful about that. You gotta be very careful about that, because this will also this will give you now is 8 in this case. This will give you now is 8 in this case. Okay, but it's because the way how the things work. Holy moly. So the thing here is that this for loop evaluation, what it's doing is to say, hey, I'm gonna take this 0, okay, we're gonna take this initial value, and then I'm going to now immediately evaluate the condition, and if it's true, okay, let's go to evaluate the block, and then evaluate the after through, which is this. And because in this case it's holding now a reference to that, holy moly, bro. Mm-hmm. 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 This is a very good, interesting question here. Mm-hmm. Mm-hmm. And it's because it's holding a reference, that's what happened. But because when you use now let, the behavior is completely different because it say anytime that I create now an execution, anytime that I'm going to for using the let keyword or cons, I'm going to now, in this case let, I'm going to now is create a new execution environment, all right, where on each one of them, if this function now holds a, is this function close over the index, is going to have now a new reference to that. So in other words, you're going to have a new reference to the when the index is 0. You're going to have a reference when the index is 1, 2, 3, 4, 5, 6, 7. And when the index is now 7, it's going to compare that and say, hey, is 7 is less or equal than 7? Yes, it is. All right. Therefore, it's going to update now this index. The index now is 8, and it's going to evaluate the condition. And if 8 is less than 7, it say no, no, no. It is not going to throw that. So in this case, it's going to show you now 7 after 1 second. You know, that's what it is. But it's because the reference, holy moly, bro. It's because it's holding the reference. And what's happening here? Mm-hmm. Holy hell. Okay. That's a very interesting question to ask. That's a very interesting question to ask here, especially for interview question. Interview questions. Mm-hmm. 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 What's wrong, baby? What's wrong? What's wrong? What's wrong? I'm telling you. The fuck? Okay, chill. Really? Mm-hmm. Mm-hmm. So now I solved that once and for all, bro. Why is index printing 8? And why index is printing 7. Why the index printing 1, or why the index print, why, okay, why is the index printing 8? Why does the index print 1 to 7 and not including 8? But it's all about the reference here, and it's all about the reference here. So that'll be all for this video. Take care. Bye bye.